Alright everyone, this is section 5.3. In this section our goal here is to be able to add, subtract, and multiply polynomials. So to add or subtract polynomials, we're going to add or subtract the coefficients of like terms. You could either do this in a vertical format or a horizontal format. Okay, so in that first example here, I have two polynomials. I'm going to first add together. So I'm getting add because it has a plus sign in between them. So all I'm going to do is line up my like terms first, okay? And I'm going to pick out my biggest one first so I can write it in standard form. Okay, so my biggest exponent here as I look across is my exponents of 3. And I'm going to add their coefficients. So 2 plus 1 is 3, and they were the x to the third powers. Now I'm going to go to the next biggest exponent, which was the 2's. Okay, and I'm going to add their coefficients, so negative 5 plus 6 is 1, and those were the x squareds. You could choose to write that 1 or not. Okay, and then my next biggest exponent is of 1, but I only have one of those terms, so I'm just going to drop it down, so plus 3x. And then I'm going to add my constants together, so negative 9 and 11 make 2. And that's what I get when I add those polynomials together there. And the next example, I'm actually going to subtract them now with that minus sign in between them. And whenever you subtract, you always want to be very, very careful with the coefficients, especially when you have to subtract a negative, okay? So again, I'm going to line up my first biggest exponent here, which are the x to the third powers. So 8 minus 3 is 5, and they were the x to the third powers. Now my exponents of 2, so negative 1 minus 2 is negative 3x squared. Okay, negative 1 minus 2 was negative 3. Now if I go to my x terms, negative 5 minus negative 1. If you need to write that out, do it. Negative 5 minus negative 1. Okay, that 2 negatives in there becomes a positive. It's like saying negative 5 plus 1, which is negative 4. That's why I need to be very, very careful when I subtract these. So negative 4x. And then my constants, 1 minus 7 is negative 6. And that's what we get when we subtract those polynomials. But say we want to multiply them, okay? In order to multiply two polynomials, you multiply each term of the first polynomial by each term of the second polynomial. And you could also do this either vertically or horizontally. So for example, what if I want to multiply this first polynomial by this second polynomial, y minus 2, in the format of my choosing, even though it says vertical format, I'm just going to go ahead and do it horizontally. Okay, so if I redo and rewrite this, I always put the polynomial with the least amount of terms first, and then the other one after it. And it's kind of like foiling. I'm going to take my first term in my first polynomial and multiply it to everything in my second polynomial. So y times negative 2y squared, well I have a coefficient of 1 in this first y. So 1 times negative 2 is negative 2y to the third power. I picked up one more y. Y times 3y is positive 3y squared. And y times negative 6 is negative 6y. And then if I take that negative 2 to everything, okay, so negative 2 times negative 2 is positive 4y squared. Negative 2 times 3y is negative 6y. And negative 2 times negative 6 is a positive 12. And now all I need to do is add together my like terms. So only term that I have of the y to the third power is my negative 2y to the third. So I'm just going to drop that down. But I have two terms that have exponents of 2, so 3 plus 4 is 7y squared. Negative 6y and negative 6y make a negative 12y. And then the only constant I have is 12. So here's that new polynomial after multiplying those two original ones. Well, let's do another one here. X plus 3 times 3x squared minus 2x plus 4. Again, I'm going to take my first term, which is x, and multiply it to everything in the other polynomials. So 1x times 3x squared is 3x to the third power. X times negative 2x is negative 2x squared. And x times 4 is 4x. Then if I take my second term there, the 3 to everything, 3 times 3x squared is 9x squared. 3 times negative 2x is negative 6x. And 3 times 4 is 12. Again, I don't have any other exponents of 3, so I'm going to drop it down. But I have two terms that are like of the x squared, so negative 2 plus 9 is 7, x squared. Then I have my x terms, 4 minus 6 is negative 2x, and then I have one constant again, that's just regular 12. So here's my resulting polynomial after multiplying those two original polynomials. So what if I need to multiply 3 different binomials? I could just do the same exact thing, okay? Write them all out first, and then pick 2 at a time. Normally I work with the first 2. So if I kind of FOIL these two, okay, I get x squared plus 1x. And if I go the other way, negative 5x minus 5 still is being multiplied by x plus 3. But I can actually simplify this one down, okay, that's on the left. X squared, 1 minus 5x is negative 4x minus 5, still multiplied by x plus 3. And again, I'm going to take that first term and multiply it by all the terms in the other polynomial. So x times x squared is x to the third. Negative 4 times x is negative 4x squared. And negative 5 times x is negative 5x. And if I go the other way, positive 3 times x squared is 3x squared. Negative 4x times 3 is negative 12x. And negative 5 times 3 is negative, 15. And now I'm just going to simplify everything by combining like terms. So I don't have any other exponents of 3. I'm going to drop that down. But I do have like terms of the x squared. So negative 4 plus 3 is negative x squared. Then if I combine my x terms, negative 5 minus 12 more is negative 17x, and my only constant is negative 15. So here's my resulting polynomial after multiplying all 3 of those binomials. When we multiply different kinds of polynomials or binomials, okay, we have some special product patterns. So a sum and a difference, if we FOIL those, that just becomes the first term squared plus the second number squared. So for example, if I multiply x plus 4 times x minus 4, that'll be x squared minus 16 after I FOIL that out. If I square a binomial, either the plus or the minus of it, it's going to result in, if I add them, 2 plus signs, but I'm going to multiply together 2 times the a and the b, okay, in the middle there, and still have a squared and b squared tacked on the ends. So for example, y plus 3 squared is my first term squared, which is y, plus the double of those 2 terms multiplied together. So 3y times 2 is 6y. And then my last term there squared, or 3 squared, is 9. If I have the subtraction, it's going to be a minus and then a plus. Okay, so the first term squared, so for example, 3z squared. Okay, if I square that, I remember take it to both of them. So 3 squared becomes 9, and z to the 4th power. And then I'm going to double those 2 terms. So negative 5 times 3 is negative 15, but if I double that, it's negative 30. and then my exponent becomes z squared. Then I just square my second term there. Negative 5 squared is 25. But if I cube or make an exponent of 3 of a binomial, okay, so if I have the plus of it, a plus b to the third power, I have a to the third power, then I multiply the product of a squared b times 3 plus 3 times the a term times the b squared term plus the cubed power of that b or second term. Okay, and for example, x plus 2 to the third power, my first term to the third power, plus 3 times a squared times b, or the first term squared times the second term there. Then the third term of that will be 3 times our first term times our second term squared, and then finally plus our second term to the cubed power, which was 8. Same thing kind of applies with a minus b to the cubed power. So the first term to the third power, like we have in this example here with p, then minus 3 times our first term squared times our second term, then plus 3 times our first term times our second term squared, minus finally our second term to the third power. So let's kind of see how we could practice some of these. So for example, I have a sum and a difference here, right? They're the same thing, but they differ in sign. So if I kind of like FOIL this, so 3t times 3t is 3t, not 3t, 9t to the fourth power, and then 3t times negative 4 is negative 12t. And if I go the other way, 4 times both of those, 4 times 3t is 12t, and then 4 times negative 4 is negative 16. And if I combine these, basically the middle two like terms go away, and I'm left with 9t to the fourth. That looks like a cube. 9t to the fourth minus 16. So that was our first term squared, so 3t squared. Remember, that should go on the outside. Gets distributed to both of those, to the 3 and to the t, so 3 squared is 9, t squared. And then of course, negative 4, that, or the second term there, I guess it should be positive 4, squared is 16, and it was our difference there, always. Next example, I have a square of a binomial, the subtraction side of it, and according to our chart, it should be our first term squared minus the double of both terms multiplied together plus our second term squared there. So our first term is 8x, and if we square that to both of those, that is 8 squared x squared, which is 64x squared. So it starts out with 64x squared. And then our minus drops down, 2 times 8x, our first term times our second term, negative 3. Okay, so 2 times 8 times negative 3, well, 2 times negative 3 is negative 6 times 8 is negative 48x. So that goes next. And then so that was our a squared, that was our 2ab, this is our b squared. Or a second term squared, negative 3 squared, negative 3 times negative 3 is 9, so plus 9 gets tacked on there. So we use that pattern or rule for our square of a binomial. And lastly here, we have a cube of a binomial, the plus side of it, and according to that rule, we take our first term and cube it, subtract out 3 times our first term squared times our second term plus 3 times our first term and our second term squared and minus our second term to the third power, or cubed. So if we follow this first, our first term squared, that looks like p cubed to the third power. And remember that gets distributed to both of them, so that's p to the third, q to the third. So p to the third, q to the third. Okay? Then subtract out our 3a squared b, so 3pq, that was our first term, squared, and then times our second term of 5. So that is going to be 15. Remember that 2 gets distributed to both of them. P squared, Q squared. So minus 15P squared Q squared. And sorry guys, these should be plus signs since we're doing the plus sign one, not the minus sign. So that should be a plus sign there. Okay, according to that pattern. Now if we go to 3 times the first term times our second term squared, that is 3 times PQ, which is our first term, times our second term squared, and 5 squared is 25 times 3 is 75 PQ. So that goes next. And finally, our second term to the cube power to the exponent of 3. So that is 5 to the third power, which is 125. And here is our resulting polynomial after cubing that binomial. So it is the faster way of looking at that pattern than actually multiplying all the way throughout it. Okay, so one at a time, just take your terms one at a time from that pattern and compare it to your original polynomial or binomial you have to cube or square. Okay, and one at a time, write your resulting terms of that resulting polynomial there.